The next concept that we are going to dive in is abstraction. So let us create a class that is called another bird. This class another bird, this class will have two methods. So the first method is public string get name, that is getter method, and it returns null. And another method is print name method, that is public void print name. When we are printing our name. And in order to get the name, we are using the just created method get name. Okay, so this another bird class, this class will be our parent class. The parent class that has two methods, get name and print name. And now we will create a child class. The child class that is called stork. And this class is child class, is a subclass of a superclass another bird. That's why we are writing extends and the name of our superclass another bird 1. So now when we want to, if we want now to override the method, so we are writing public string get name, and we are returning stork. And let us access this, execute with the main method public static void main string and arguments. And now we want to use the method print name here. And we are just writing new stork. So let's make it in a proper way. Let's create an object. Stork 1 stork is new stork 1, and now we are using our object name to access the method print name. And we see the result stork. So this is just, as you have already learned, this is the very known concept already now about parent class and child class. So when you want to define a class as abstract class, you are writing abstract. Let us say that our class another bird is now abstract class. And abstract classes, they have some specific characteristics. So abstract classes. Let us use the multiple line documentation. So the first, what you have to remember, that abstract classes, they're used as superclasses. Used as super classes. It means that in this class you will not create any object from this class. That is, that these classes will not be instantiated, that is, they cannot be instantiated. Because you will be able to use them only in another class as superclass, when you're referencing to this class as superclass. However, you will not be able to create in this way the new object from another bird class. So that is that you would create here or somewhere else a main method and creating an object from another bird. That is not possible for abstract classes. These abstract classes, they can have both implemented and not implemented methods. They can have implemented and abstract methods. So for example, here you have the method that is already implemented. You can also have an abstract method. For example, let us say that this method will be now abstract, and then you will just have to take out curly braces and put abstract here before. So now this is our abstract method, and this method is implemented method. That is, the difference is that in abstract method you do not have implementation, so you do not have curly braces where you write your statements. And in implemented methods you have curly braces and you put here your statements. So both of those methods are eligible for abstract classes. The condition is that if you have in any class one abstract method, then this class has to be abstract. So classes that contain abstract methods must be abstract themselves. And when you want to define abstract class or abstract method, if you want to define abstract class, you're putting the keyword abstract before the class. And if you want to define abstract method, then you are putting here the abstract keyword. So now we have two methods here, one abstract and another implemented. And here in our class, nothing changes. So if you just run this class, this main method, then everything will stay the same. Just to show you that if you will, for example, put here main methods, let copy this here, and you would like now to instantiate an object of another bird. that is new, another bird 1. You will see now here an arrow that tells you cannot instantiate type another bird 1, because now this bird is abstract. If this class would not be abstract, then we have to get rid of our abstract, then it would be possible here. However, this is now not the case, so we just comment this out. So the next topic are interfaces. That is also a very, very interesting one, and this topic, interfaces, is pretty similar to our abstract classes. So we will now create a class that is called nocturnal. That will be here. So our class nocturnal will be now interface. So first, let's now I will explain you why interfaces are so important. So what you have to remember about inheritance is that Java has only single inheritance. Java does not allow you to use multiple inheritance as, for example, C++. Why? Because the experience with C++ has shown that using multiple inheritance leads to a lot of errors during the programming and execution of programs. That's why in Java was decided to use only single inheritance. So what is single inheritance? What is multiple inheritance? You can have only one parent for any numbers of children. That is, you have one single parent, one single subclass, and you can have once more. So you can have one single superclass and multiple subclasses. That is single parent and multiple children, a lot of children. So the direction is from top to the bottom, one parent, single parent, and a lot of children. The multiple inheritance would be that you have, for example, two parents, mom and dad, and you have one or multiple children, doesn't matter. So this relationship is not possible in Java. You can have only one parent, only one superclass. However, there are some cases when you do need to implement multiple inheritance. And for example, your class has to inherit from several classes. Using inheritance in a sense of superclass and subclass is not possible. So in this case, the interfaces, they come as a help, since interface is also an abstract class, and you can have multiple you can inherit from multiple interfaces. So for example, if you need to inherit from several classes, you can inherit from one superclass and additionally from multiple interfaces. So this is kind of workaround. So let's come to an example with our interface. When you want to define an interface, you are taking out the class keyword and you're putting interface here. So the interface is an abstract data type that declares a list of abstract methods, and it can also have variables, but they have to be final. So now we will write one method inside that is hunt. And as you remember, the abstract methods, they don't have implementation. So you don't write curly braces here. You just put the method name and just normal brackets. All methods within interfaces, they are implicitly assumed to be public. So you can just write in this way without specifying public, or you can put here public. That is actually the same. So you can also have here any variable, but this variable has to be final. Once more important to remember is that any methods, any abstract methods that you will declare here without any initialization, all of them must be implemented within the class that will be implementing this interface. So let's have a look on an example. So we have here interface with method hunt. Now we will create a method that will inherit, that will implement this interface. So this method will be called short-eared owl, short-eared owl, and we want now to specify that this class will use the our nocturnal interface. That is, it implements this interface, and you're just writing implements, the keyword implements, and the name of your interface, nocturnal 1. So now you see already here some note that the type short-eared owl must implement the inherited abstract method nocturnal 1 hunt and brackets. So this is already remark for you that you have to implement it. And we are doing this here. So we are now writing public integer hunt method, and now we have to give the implementation to this method. That is, we are specifying this implementation within the curly braces. This here will return 10. So if we will now create a main class and we will call the hunt method, then we will receive 10 printed out to our console. So let's write another interface that is called can fly. And we're specifying that this is an interface, can fly, and we are writing one method of void type flip. So this method flip must be implemented in a class that will inherit this method, and we will now create a method, a class owl, and this class owl will now use this very nice visibility to implement two interfaces simultaneously. So we are using first the keyword for implementation of inheritance of interface, that is implements. And now we are writing all the interfaces that we want to use now and separating them with comma. So first we will implement nocturnal and then can fly. So let's now separate them so that you can see. Here's our nocturnal interface. It has one method hunt, and our can fly interface has one method flip. So in our all one class that implements both of those interfaces, we have to implement now these two methods. So we are writing, actually we can copy this, and now we have to put here the implementation inside. We are returning 5, and the method from our interface can fly will receive the print line statement with the word flap. So now if we will create a main method and we will run those two methods, then we will receive in the first case 5, in the second case flap. So next we can even make our relationship even more complicated. So let us create another interface that is called has big eyes. And this interface will be combination of those two interfaces. That is, this, let us say that this interface will take those two interfaces and combine them. So in this case we are writing extends nocturnal 1 and separating with comma and can fly. And actually we don't have anything inside, since this interface has big eyes, will automatically have these two methods already inside. These not methods, two interfaces, the methods of those two interfaces. And now we will create a class that will implement this new interface. So we'll create now Snowy Owl class that we'll put here, and this class will implements the interface has big eyes. And you see already here that the note that this our class has to implement the method nocturnal 1 hunt and the method from can fly flap. So even if we don't have here any methods inside, however, this interface has big eyes extends to another interfaces that do have abstract methods. And since these abstract methods have to be implemented, we have to implement them here now in our new class. So we will write now here public integer hunt, and we will return 7, and another method public void, that is actually the same as here flap, void flap, and putting inside the implementation. So system out print line, and we are printing flap. Flap. So So here you see this very nice relationship when we create several interfaces. And these interfaces can combine another interfaces in itself and then further be implemented within one class. In this way, you can overcome the shortcoming that Java can use only single inheritance. The Java can have only, the classes can have only one parent, only one superclass. Since you can use interfaces to make your implementation of the methods in your class even more on more advanced level. So the next method, the next concept that we are going to look at is polymorphism. So for polymorphism, let us first close all this. Classes, and let us create a new class that is called Primart. This public class Primart, it has one method, public boolean has here, and this method returns true. This is our first class. So let us create interface that is called has tail. This interface has tail. It is interface, and it has one abstract method, that is public abstract boolean is tail striped. So our Primart is here the superclass, and has tail is interface. So now let us create a class that will inherit from our superclass and will implement the interface. And this class is called Lemur. And here inside we specify that this class inherits from class here, that is extends and implements. So now you immediately see that we have to implement the method isTailStriped, and that's what we will do at the very beginning. We are now implementing this method. So we will return public boolean. Oh, actually this method, sorry. So public boolean is striped, this one. So we are putting here curly braces and putting here our statement that is return false. And we are now have also one variable here that we will put actually at the beginning according to the convention, that is public integer age, and we initialize this variable with integer value 10. We will also create now main method. Where we will write our what is here? Abstract should not be here. And now we will have a look on polymorphism in practice. So the polymorphism, this is the property of an object to take on many different forms. That is, that Java object, it can be accessed using many different references. And let us just write it here. Java object may be accessed using a reference and here we will now specify several types of references. So once more, we can access the same object in several ways. So the first type that we will now consider is when we can access the object with the same type as the object. So the same type is the object. It means that the type is lemur1. So we are going to first maybe just put it here, create a new object lemur1, lemur, that is new lemur1. So we have now our object. So accessing the object with the same type as object means that we are using this lemur object in order to access, for example, our variable age. So we are using for this purpose the system out println statement, and we are using lemur and age. So in this case we are using the same type as object lemur, and this is our object lemur. The next option is when we are using a reference that is superclass of the object. So here we have superclass primart and we are using this reference. So Java object may be accessed using reference that is a super class of the object. So we are now creating primart 1, primart equals to lemur. And now when we want to access, for example, the method has hair, then we are using our primart has hair, and that's all. And the last type is when Java object may be accessed using a reference defining an interface the object. So defining an interface of the object. And of the interface the object implements. So this implementation, it can be directly or direct implementation of a superclass. So directly or through the superclass. So now let's use this kind of reference. So we are now using our hasTail1 interface, and we are saying that now it has tail equals to lemur, and we are printing the statement, and we are accessing now this method with this data type hasTail with dot. And we see here errors. What is it? Type mismatch, cannot convert from lemur1 to primate1. Yeah, because we have to specify that this is 1 and 1. The name of our interface and our superclass has to match here. That was the error. And now if we will execute our code, then we will receive 10 true and false. So this is, with this example, you see how the object can take a lot of different forms using the concept of polymorphism. So the next topic, just briefly, are packages and then garbage collection. So packages, you see here how your projects, how all your classes, they are organized into packages here. So you see here several packages and all of your classes are here inside. So the first that you have to remember about packages is that putting your classes into packages, first they provide you a very nice structure, but second, very important, you can have the classes with the same name in different packages. For example, let us have a look here. We have here book, our book class, and we have in our second package class that has the same name. So this is valid. If you want to use some specific class from one package in another package, then you have to import those classes. So for example, let us say that we have a new class test, and we will open, let's here close all our classes here. This is our test class, and here we will now open Swan. So if we will copy something from here inside to our test class, then automatically you have here import statement that appeared here. This is because you will need to refer to some specific classes that are in another package, so you are specifying here the import statement. So important is to remember that you can use a lot of the broad functionality of Java, that is, you can use already created classes. The classes that were created by other programmers, by your team members, by someone else, or maybe also the classes that are already in Java there. And in this, using the import statement, you can just import those classes and then use the functionality of those classes within your code. So you don't have to write the same code again. You don't have to copy paste it even. You are just writing here import statement. So that's actually all what I wanted to tell you about the packagers. The last concept is about garbage collection. So garbage collection is about removing of unused objects from your memory. In other languages, for example C++, this is not automatic. So in those languages you have to write the specific code to delete, to make this the memory that was allocated to specific objects that do not exist anymore, to make this memory free. In Java, this is done automatically, so you don't have to write any specific commands to this purpose. If you have, for example, two variables and one variable is assigned number 1 and another variable is assigned number 2, and then you write that the value of first variable equals to the value of the second variable, then automatically you don't need the memory space that was allocated to the second variable. So it depends on which direction, so you just need the memory allocation only for one variable, and another one, even with the value inside, will be freed. So it means that any object in Java is eligible for garbage collection. This process is called garbage collection when this object is no longer accessible through any variable. For you, if you have to understand whether the object is already eligible for garbage collection, the best way is to draw the diagram that you have seen on your lecture slides, where you just after each operation you are drawing the errors, for you to remember whether any variable is still referencing to a specific object. And the last but not least, your homework. So the homework consists of the 3 parts. The first part are the codes that you will find in your lecture slides. Please copy them into Eclipse environment and try to understand them. And you will find a lot of like all codes from our exercise. They will be uploaded to Moodle, so please have a look on them too. Then the quizzes. So the quizzes that you have in your exercises, the quizzes starting from exercise 2, 3, 4 and the next exercises, they are combined. I combine those quizzes from different sources that are preparing to Oracle examination for Java Fundamentals and OCP Part 1 exam. So these quizzes will help you first to understand what kind of questions can be on those exams, but also these quizzes will prepare you to our exam that you will have in July, hopefully. So please do them, and if you have any questions to quizzes, then just write to Moodle. The programming tasks, they are also will be also uploaded to Moodle, and the solutions as well. So thank you for your attention and see you next week. Bye.